So, Chapter 3, Lesson 1 is integers and absolute value. Okay? So, numbers like like 5 and -8 are called integers. An integer is any number from the following set. Where we have this dot, 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 that means it continues without end. So if I'm looking at this set of numbers, we've got -1, -2, -3, -4, dot, dot, dot. That means that this set of numbers will go forever to infinity in the negative direction. Okay? It also, on this side, we have 1, 2, 3, 4, dot, dot, dot. That means that it continues without end in the positive direction also. Okay? So, the first problem here, it says, the bottom of a snowboarding halfpipe is 5 meters below the top. Circle an integer you would use to represent that position. So, which one would represent 5 meters below the top? That would be -5. Very good. Now, how about this next question? It says, describe another situation that uses negative integers. Here is a thermometer showing the temperature of 5 degrees below zero, below freezing. Is everybody clear? All right. So, the first thing we're going to do here is we're going to identify and graph integers. Please make sure you write down these definitions and this little point right down here. So, here, negative integers. I want you to make sure you write this down. Negative integers are integers that are less than 0, and they are written with a negative sign. And positive integers are integers that are greater than 0, and they can be written with a plus sign. They could also be written without a sign at all. Okay? Also, down here, I want you to know that 0 is neither negative nor positive. Now, integers can be graphed on the number line. To graph an integer on the number line, we want to draw a dot on the line at its location. Okay, so make sure you write down how to graph an integer on a number line. So if we look at this number line here, you can see we've got all of the positives. See, there's +1, +2, +3, +4, and so forth. So that goes, this arrow here, see the arrow right there? That indicates that it goes in the positive direction to infinity. Goes on forever. On the other side, on the left-hand side of the number line, we have -1, -2, -3, -4, and so forth. And once again, this arrow signifies that it goes in the negative direction to infinity. Okay? On this number line, you will see that they have labeled positive, the plus sign for the positive numbers. But, like I said before, you can also write the positive integers without the positive sign. So, for example 1 and 2, it says write an integer for each situation. So, an average temperature of 5 degrees below normal. So if we're looking at a temperature of 5 degrees below normal, okay, because it's below, it's going to be a -5, okay? If we have an average rainfall of 5 inches above normal, that's going to be a +5. And again, look at right here how they write it. They write either +5 or just a 5 with no sign at all. So here we want to write an integer for each situation for the guided problem. So example A says 6 degrees above normal. So is that going to be a positive or a negative? Positive. That is going to be a positive. So you're going to write either a +6 or you can just write 6. Okay? For the next one, for example B, it says 2 inches below normal. And of course, that's going to be a negative. So that's going to be a negative 2. Example 3. Here, this is graphing a set of integers on the number line. So when we graph on the number line, once again, make sure you know this is what you're supposed to do. You're going to draw the number line, and then you're going to draw a dot at the location of the integer. So you already wrote that down. You don't have to write it down again. So here we have positive 4. You just put a dot right on positive 4. You have negative 6. You just put a dot on negative 6. And 0, you put a dot on 0. And that's all there is to graphing on the number line. Is everybody clear? Yep. All right. So let's take a look at our got it examples. So these I want you to write your number line. So for the got it, we want to graph each set of integers on the number line. So here we have negative 2, 8, and negative 7. So when you draw your number line, you need to make sure that you include all of the numbers necessary. Okay? So we have negative 2. There's negative 2. You just draw a dot on it. You have 8, positive 8. And you have negative 7. And that's it. So now, when you have the numbers, when you have, what I wanted to point out to you is that when you're looking at the number line, you can see which ones are the smallest to the largest, right? Because on the number line, smallest to largest goes from left to right. Is everybody with me? So look at these negatives. If we look at the negatives here, we have negative 7 and negative 2. Negative 7 is a smaller value than negative 2. When we are looking at negative numbers, the larger the digit, the smaller the value of the number. Is everybody clear? All right, so now for example D, we have negative 4, 10, negative 3, and 7. So when we put them on the number line, there's negative 4, there's positive 10, we have negative 3, and positive 7. Is everybody clear? Yep. So the next thing we're going to talk about is absolute value. Please make sure you write down this definition for absolute value. The absolute value of a number is the distance between the number and 0 on the number line. Now, remember, absolute value is a distance. And when you are measuring a distance, you can never get a negative measure. Is everybody with me? So here, if we look at this example, we've got negative 5 and we have positive 5. Now, the absolute value, the way you can think about it, elementary, like you can say how many hops does it take to get to 0 on the number line. Okay? So, negative 5, it takes 1, 2, 3, 4, 5 hops. So, the absolute value of 5, how many hops does it take to get to 0? 5 hops, right? So, the absolute value of negative 4 would be 4, because it takes 4 hops, right? The absolute value of positive 4 would be, how many hops does it take to get to 0 from 4? 4, right? So it's always, when you take the absolute value, it's always going to be a positive number. Is everybody clear? So down here, these are the symbols for absolute value. Now, I like to make sure that my absolute value symbols are larger than the number, okay? The reason for that is if you don't, let's say we have the absolute value of 5. See what that looks like? Looks like 151. So I want you to make sure that you don't write it like that. I want you to make sure that when you are writing the absolute value of a number, you write it a little bit bigger than the actual number. Is everybody clear? Now, numbers that have the same distance from 0 on a number line have the same absolute value. Okay, so if it's 5 units away in the negative direction, it's still 5 units. If it's 5 units in the positive direction, it's still 5 units away from 0 on the number line. So that means that negative 5 and positive 5 have the same absolute value. Okay, now I want to give you a little extra information here. If you have two numbers on the number line, two different numbers on the number line, that have the same absolute value, then those two numbers are opposites. You guys remember we talked about opposites at the beginning of the school year? Here, negative 5 is the opposite of positive 5. They have the same absolute value. Negative 25 and positive 25 have the same absolute value. Those two numbers are opposites. Is everybody clear? Now, for the example, we're going to evaluate the absolute value. I want you to make sure you write down this part over here, this order of operations. It says the absolute value bars are considered to be a grouping symbol. Do you remember at the beginning of the school year when we changed PEMDAS to GEMDAS? Okay, because the G stands for grouping symbols, right? So here, the absolute value is also considered a grouping symbol, so that when we are when we are evaluating expressions, we treat those absolute values just like we treat parentheses. Has everybody got that? Okay, so here, example 4, we just want the absolute value of negative 4. So that's just 4. You don't have to show any work there. Here, for example 5, we have the absolute value of negative 5 minus the absolute value of 2. So what we're going to do here when we simplify this, or evaluate this, we're going to evaluate the absolute value of negative 5, which is 5, right? Minus the absolute value of 2, which is 2. So we have 5 minus 2, which is equal to 3. So let's do these got it examples, okay? So, for example E, we will have the absolute value of 8. The absolute value of 8 is 8. Very good. Always positive, right? Example F. Make sure you're writing down all of your examples, please. We have 2 plus the absolute value of negative 3. So when we evaluate, we have 2 plus the absolute value of negative 3 is positive 3. So we just write 2 plus 3, which is equal to 5. And again, if you are showing your work correctly, you should see your inverted triangle. Okay? How about example G? The absolute value of negative 6 is 6 minus 5. So 6 minus 5 is 1. And that's all there is to it. Okay? I've got one more example. Nick climbs 30 feet up a rock wall, then climbs 22 feet down to a landing area. The number of feet Nick climbs can be represented using this expression. How many feet does Nick climb? So here, the expression that we are going to evaluate or simplify is the absolute value of 30 plus the absolute value of negative 22. So the absolute value of 30 is 30 plus the absolute value of negative 22 is 22. So we have 30 plus 22, which is equal to 52. So Nick climbs 52 feet.